Okay, let's start. Hi, so my name is Vladimir, and the title of my talk is One Cable to Rule Them All. And actually, the name of this cable is Any Cable. Okay, let me introduce myself. So I'm Vladimir. I was at Matsushima 2 days before, pretty cool city. But I came from far away, from Moscow. It's in Russia. Even if Russia is pretty close to Japan, Moscow is too far away from it. It's 9 hours flight. And you can find me on GitHub and Twitter with these handles. Check them out, feel free. And I'm working at a company called Evil Martians. And actually today is my 2nd anniversary on Mars. So I'm speaking at RubyKaigi, it's pretty cool. What is Evil Martians? What are we doing? A bit of advertisements. So we're doing product development for big companies, small companies all over the world, mostly in the United States. And of course, we're doing a lot of open source stuff in front-end technologies, Ruby, and some command line tools, whatever. And we're writing about it in our beautiful blog. You probably read our articles translated into Japan. Thanks to Hachi for that. And today I'm going to talk about cables. Well, and a couple of particular cables. And let's start with the first part. So, cables. What is cable? By cable I mean any tool which is used to develop a real-time application. So libraries, frameworks, maybe services, whatever. So real-time applications. It's all that applications where we need some kind of asynchronous communication between client and server. And so messaging, live notifications, probably online games, and so on and so forth. And in Ruby world, we do have a dozen of different cables, so different libraries, which we can use to build real-time applications, actually. But unfortunately, we are likely not going to use them, but instead to rely on some non-Ruby cables. Because, well, there are some languages, technologies, which do better real-time stuff. They support concurrency out of the box and so on and so forth. And the Ruby, well, is not yet. Hopefully in Ruby 3, as we already know and learned today from Kaiichi Sasada talk, we're going to have guilds, and that probably will add some kind of concurrency support to Ruby. But today, what should we do? Does it mean that we should leave our wonderful Ruby world and go to somewhere else? My answer is definitely not. We should not. And in this talk, I'd like to show you how can we write high-performant real-time applications in Ruby, mostly. And let's start with a problem called Action Cable. Why I call it a problem? Well, I'm going to reveal in the next slides. But why Action Cable, actually? So we got a lot of cables. Well, it's the most popular cable right now because it's a part of Rails. Rails is the most popular framework, so that's the logic behind it. First, let me remind you, if you're not familiar with, by the way, who is familiar with Action Cable? Raise your hands. Oh, quiet. Cool. And who's using it in production? Cool. That's good, actually. It's usable sometimes. So, Action Cable. What it is consist of? So we got a server. That's a part which is responsible for handling our sockets, our connections. We got a broadcaster or PubSub part, which is responsible for subscribing clients to streams and doing all this message transmitting stuff. And we have an abstract layer called channels, so it's just a framework, Ruby framework, to describe the logic behind your real-time communication. And the channel class itself is just a Ruby class, and it looks very similar to controller class, well, just a kind of controller for your WebSockets. And the coolest thing is about Action Cable is it's really easy to write a working real-time application in 5 minutes. So that's pretty great. That's why Action Cable is cool. Yeah, let's wait until the end. Cool, it works. Is this application, sorry. Okay. Is this application really works? Is it usable? Does it scale? A lot of questions we can ask before my presentation continue work. Oh, yeah. No, too much, sorry. Yeah. And so, yeah. So let's consider some benchmarks. Sorry for that part. It's pretty heavy GIF. I'd like to show some numbers. And first, let's consider a shootout benchmark, which compares different WebSocket applications written in different languages, so such as Erlang, Golang, Clojure, and of course, Action Cable. I haven't tried Clojure, sorry. So what is benchmark about? So we try to measure the time it takes a server to broadcast the message to all the clients. So let me explain it more simpler. Consider I'm a server and you are all the clients. And if someone, say Bozhidar, tells me something, well, Ruby is cool, my duty is to tell everyone else, well, Ruby is cool, Ruby is cool, Ruby is cool, and so on and so forth. So, and we measure the time it takes me to do that. And that's our main characteristics of our real-timeness. So the faster we do broadcasting, the better our real-time application is, because no one wants to wait for dozens of seconds for yet another chat message to appear, right? So let's consider the numbers. And that's how it looks like for our Action Cable with different number of processes, Puma process running, and say Golang and Erlang applications. So we can see that, well, when we deal with thousands of connections, Action Cable is not cool anymore. And we should take care of it. So the good thing that Action Cable is still usable, but you just don't want to have such a crowded streams with thousands of subscribers. So if you have streams with dozens, maybe hundreds of subscribers, it's pretty okay. The latency is below 1 second, generally. But if you have a crowded stream, then the latency grows and you're not at real time anymore. Another problem here is that it doesn't matter what your broadcasting model is, the resources usage is going to be high. And let's see the numbers again, or some kind of graphics. So that's how your CPU feels like when you're doing broadcasting with thousands of connections. It's not doing very well, right? That's not the main problem, actually. We also have memory issues. Well, the chart shows the memory required for handling 20,000 idle connections. So we just have idle connections that do nothing. There are no broadcasting, no message passing, but they just connected to the server, and to handle all that stuff, we need that amount of memory. That's just a benchmark. And benchmarks are not the right thing to learn from, right? So we need some real-time data. So I got a story for you. And the story looks like this. The project called equip.com, doesn't matter what it's doing, it's too complex, used to use Action Cable in production on Heroku, and they have to have more than 20 1x dynos to handle, I haven't wrote it, but it's about 5,000 connections only with 20 gigabytes of RAM. And they still experience memory issues. What could be the cause of this? Why we do need so much memory for doing this real-time stuff in Ruby, in Action Cable, more precisely? The first reason, one of the reasons, is the way Ruby WebSockets usually implemented. Using this dirty hack in Rec called Rec Hijack, which just allows you to directly access the underlying I/O, say TCP socket, and do all the stuff kind of manually within your Ruby application. So we need a separate I/O loop to handle concurrent connections. We have to parse WebSockets protocol to decode and encode frames. We have to do all this stuff in Ruby. Oh, probably write a C extension, but no one haven't done it yet. And the good thing here is that we already have a Rec API proposal, which is kind of new, and it's not there yet. But the idea of that proposal is exactly to extract all this low-level stuff into the web server itself, say Puma or something else, and implementing something different from Ruby through C extensions probably, and to eliminate this overhead. But we're not there yet. Another problem with Action Cable and actually other implementations, and these frameworks are trying to be more like a Ruby way, object-oriented way, and they keeping all the state, keeping persistent state. So, for example, every Action Cable connection requires that amount of objects created in different parts of different layers of abstractions. So just to be initialized. So that's the minimal amount of objects and the corresponding memory, pure memory. So it's just the number of objects multiplied by the size of an object to initialize one connection. And also, speaking of Action Cable, there is also a problem with its PubSub implementation. Because, well, I found out that it's doing round-trip JSON encoding for each client for every message sent during the broadcast. And that's, well, not so efficient because, first of all, it's a computational overhead, and secondly, to encode and decode JSON, we have to allocate strings. Strings are heavy and affect our memory. And actually, I already proposed a pull request to Action Cable to get rid of this problem. It's pretty small. Thanks to Aaron for teaching me how to show divs yesterday. So, what does it mean? Actually, these two things together probably could lead to heap fragmentation, right? Well, I'm not the best man in this conference to talk about heap fragmentation, but I can draw a picture. That's a heap dump of an Action Cable process after having some kind of stress. And we see that we got a lot of empty spaces. So red dots are live objects, white, so empty dots are empty slots in our heap. So if we calculate the amount of empty slots, so the ratio here is about 60% of heap is empty, but due to this kind of stripes, we cannot deallocate it. So, and these two. And that's just after running some benchmarks for 10 minutes. So that could explain why in production we have to add more and more memory when using Action Cable. So that's the problem. What could be a possible solution? So wait for guilds, implement new Rake API, migrate to Elixir, Clojure, Golang, Rust probably. That's all not too interesting, I think, for RubyKaigi conference. Let's talk about another solution called AnyCable. And give me a second to have a drink. Sorry. Bull. Okay, what is AnyCable? Well, AnyCable is a project which aims to enhance and improve and actually fix Action Cable by combining its kind of business logic, its channels, with other technologies such as Golang and Erlang. How can we do that? So, in Action Cable, we have these 4 layers. And the layer which is responsible for the most of the low-level work, for sending messages, for keeping connections, is the server. What if we can just get rid of this server from our Ruby process and move somewhere else, right? And that's exactly what Anycable is doing. It leaves all the Ruby part of Action Cable, your channels, your code that is written, and handle all the low-level stuff with kind of sockets and broadcasting. So the diagram looks like this. It's kind of simplified, but the idea is the following. Our WebSocket clients connect to the WebSocket server, and it somehow communicates with the Ruby or Rails application to perform all the actions, some subscribing, RPC call, whatever. And that's the idea. The question here, how to efficiently communicate between WebSocket server written in some other language, say Golang, with Ruby. And just keep in mind that we're trying to build high-load applications, so this communication should be pretty fast and efficient. So the answer is gRPC. What is it? gRPC is a RPC framework developed in Google. It's not an official title, but we can say it like this. So it's universal RPC framework. So it means that we can write our servers and clients in different languages, and they can communicate with each other pretty easily. And it's built on top of two technologies, actually, so HTTP2 and protobuf. So we use HTTP2 with its streaming capabilities to pass messages encoded with protobuf protocol. And it's just kind of an extension for protobuf, so we can use the same description files, proto files, to describe our service. So Anycable service is pretty simple. It just contains three public methods to invoke. So when client connects, we call connect to authenticate the connection. Any other action, we call the command, and when client disconnects, we call disconnect. It's pretty clear. So the final diagram is like this. So we had a, say, Golang server, which communicates with RPC server by HTTP2, and for broadcasting from other parts of our application, we currently use Redis. That's just a temporary solution. Another question could arise, okay, how good is this connection, right? Maybe it's a bottleneck, because we're doing some HTTP stuff for every action. Well, it turned out it's pretty cool, so we can hit these numbers. It depends on the level of concurrency. The maximum that we can achieve is this, though not all RPC is just RPC which is doing nothing, just accepting parsing messages. That's a Ruby implementation limitations current, at least. Well, it's well enough to build such a solution on top of it. So what about benchmarks, right? So we have a couple of WebSocket server implementations, one written in Go, one written in Erlang, because I'm a big fan of Erlang and not Go, but I have to. So speaking of CPU usage, it's pretty cool. We can see that we got a lot of resources left for the same amount of stress. And of course, due to the implementation, we have the same performance, real-time performance as just plain Ruby or Go applications. And going back to the story, after the project Equip.com migrated to Anycable, they decreased the amount of dynos by 10, and okay, they just pay less, that's great. So, what are the key features of Anycables? Anycable doesn't have long-lived objects, so it doesn't store anything in your Ruby process. Instead, we use some kind of encoding, decoding stuff of all your state, which is stored within WebSocket server and passed on every command as a part of the request, and lazily restored if we need it. So that's kind of implementation details. Actually, the implementation is pretty simple, so that's how RPC server looks like. We built some kind of socket mock to act like a real socket for action cable. That's the way we, well, doing this cool Ruby stuff like quacking like a socket, and just handling this kind of events. So I've already published my slides, so you can check the code later. There are room for improvements. We actually do not need to build a socket object for every request and a connection object because well, we can reuse them with different identifiers, but that requires some work. I'm not sure that it will increase the performance. And of course, the POP-sub implementation, which lives within WebSocket server, which is its written is in Golang. In my case, is much more efficient than the one we can write in Ruby. And some other interesting features, for example, zero disconnect deployment. So what happens when you deploy your Action Cable application? Well, it should disconnect all the connected clients because you have to restart your Puma server, right? And that could cause some problems when you have a lot of clients connected, you deploy your application and then you experience a kind of connection avalanche, which can cause some other problems, who knows. With Anycable, there is no such problem because Anycable WebSocket server is logicless and it's just a proxy server. So you don't have to restart it for every deploy, it's just up and running. And your clients stay connected. And to make it more smooth, you can add a kind of load balancer, such as Envoy proxy, and then you get real two-phased deployment phase with all the clients connected and everything working. And also as a side effect, we added a support for comprehensive analytics into Anycable, and now you can learn what's happening within your WebSocket server. It's compatible with Prometheus, for example, and you can write your own expert. I'll show you a little bit later how, if I have time. So the coolest thing with Anycable is just a plug-and-play solution. That's everything you need to do to enhance your Action Cable application with Anycable. Just add a gem, configure it, and run WebSocket server, and that's it. You're running high-performant WebSocket server. And in terms of compatibility, there are some features of Anycable that are not supported yet, but most of them are supported. So if you're looking for something to improve your Action Cable performance, check it. What else? Well, actually Anycable is not a Rails-only project. You can use it without Rails, but you need something to write your channels, right? Here comes Lightcable. That's a companion project. It's just implementation of Action Cable channels framework with zero dependencies. And it's compatible out of the box with Anycable and with Action Cable clients. So it looks pretty like Action Cable, sorry. But you can use it with pure rec application or maybe with Hanami. And we're currently working on Lightcable integration with the new rec API too, with iodine server. So check this out. And we reached our final chapter, I guess the most interesting one, but I have to do this right again. Sorry. It's the drawback of having this kind of mic. I cannot do any stuff. So, I was thinking how to improve Anycable a little bit more. Yeah, I wanted perfect performance. The observation I made that in most cases, channels look pretty simple. We do have this kind of code. And actually, it doesn't contain any specific kind of heavy logic when you deal with models, accessing your database, and whatever. You just subscribe a client for a particular stream. So what about not calling RPC in that case? We do not need it. We can eliminate this unnecessary call and execute this Ruby code within our Golang somehow. So what are the options here? Have you heard about Gobi language? No. You should check. It's a pretty new project. It's Ruby-like language. It's close to Ruby, and it's written in Go. And I was thinking, well, maybe that's the case. I can try to use it because this kind of stuff which I'd like to implement is compatible with Gobi, so it could be simple. But it turned out that, no, it's impossible to use it as a Go library, so you cannot combine Gobi and Golang. That's strange, but, well, that's a limitation. Okay, we had another option, and the option is called mruby, which is a project a little bit younger than Ruby. I guess in this audience is pretty familiar with it. So it's a project, it's embeddable Ruby. It's Ruby implementation has different kind of goals. So it's to be used in devices and within something else. So we want to embed it. Actually, I already tried mruby, and a year ago or somewhere, I wrote a command line action cable client, cross-platform command line client, actually, written in mruby. That was my first experience, so I already known all the pain of building cross-platform applications with mruby. So I decided to give it a try again. And by the way, I even contributed to mruby someday. Well, that's just for reference. So I found that project called Go mruby, and actually today, if you visited Terence Lee and, sorry, Arthur, yes? Yeah, your talk, so you already mentioned Go mruby. So that's the library I decided to use for my project. Quick note, just for the better readability, I removed all the error handling code from my Go examples because it doesn't make sense to provide them. Let's read more easily. So, mruby Go, what is it? It's kind of a wrapper over mruby VM, so it allows you to launch mruby virtual machine and communicate with it, so some kind of API. I built my own wrapper around it called Engine, like a, I don't know, if you heard about mruby Engine by Shopify, that's the name came from. It's pretty simple, so we just initiate a new mruby VM, and we can load some Ruby code into it to execute later. So that's an example how we can load the code. We should initialize a context for mruby, so it's, and well, do all this stuff manually, actually parsing, generating code, and then running it into the VM to be executed later. So some examples. Oh, that's error handling, I forgot to remove. Okay, so I just give it a try and wrote this test, and it worked. And I found, well, cool, I can write Ruby within Go. Let's do something useful. And the first thing I've implemented was custom metric support. Just to, I don't know, just for nothing, just to try mruby within Go in production. So it's an ability to write metrics in your format from any cable. Not so useful, but at least I checked that it worked. Okay, then the main idea. So we already seen this example of channel method, which is pretty simple, subscribe and stream from something. The idea is the following. We may ask our RPC server, say, so please tell me which methods or which channels are so that simple that we can run them within Golang. Actually, this part is not implemented yet. I have some ideas how to do this, how to extract method source and how to analyze it using kind of maybe Reaper stuff or parser stuff, whether it's too simple to implement within mruby or not. And next two things is to load these methods into mruby VM and invoke them instead of calling RPC. So I built a kind of mcache struct, which is used to generate this mruby channels. We can load some default code from the file. It's not interesting, actually, so it's implementation of action cable channels, API, some kind of transmit, stream from functions, and so on. And then we use maction struct, which is just a wrapper around one particular method. And it looks like this. So we generate a Ruby class which is inherited from some predefined class, and we call this identify helper to name a channel and load it into our virtual machine. And then we just access our module and call a predefined method perform, which do all the stuff. So we can get all the required information from it. Well, I did some benchmarking, and it turned out that it's much more faster than calling RPC, even if it's RPC running locally. Usually you run RPC server on a separate machine, so the overhead is going to be much bigger, so it's going to be dozens of milliseconds. And in case of Ruby calls, it's just 1/20 of a millisecond, so it's really fast, and we can eliminate unnecessary gRPC calls. So it's currently just experimental feature, but I think it's going to be part of any cable Go soon. Well, we have 5 minutes left to discuss what this talk was about. Actually, well, just to summarize, so what have we done? We moved low-level stuff from Ruby to Go and glued them together with gRPC, and it appeared to be a pretty good combination, which works, well, really good under the high load too. And the second part, we move in some parts of Ruby, user-written logic into Go to execute with mRuby to make it even more better. So what does it mean? Well, in general, it means that we can do WebSockets in Ruby, but in order to be high performant, we should add something else. Maybe other languages, maybe other Rubies. And some new features like a Rec API will probably help us to, well, make WebSockets and pure Ruby better, but we still depend on ourselves. So, for example, writing efficient PubSub implementations in Ruby is still difficult, and memory problems are still there. So, again, we're waiting for Compacting GC. Probably this talk, in 4 years when Ruby 3 is going to be released, won't make sense anymore. We will have the better Ruby, but in the nearest 2, 3, 4 years, that's still pretty relevant. I published my slides already on SpeakerDeck, so code examples and everything else is available. And that's it. I got stickers. Thank you very much. And we have 4 minutes for questions. Please find the microphone, turn it on, and ask your question. Thank you.